Okay, today we're going to see the computing entailment in artificial intelligence. Okay, what is the computing entailment? In AI, computing entailments means figuring out what conclusions we can draw from a set of facts, rules, and knowledge. This helps AI system to make decisions or solve problems by understanding what logically follow from the given information. Okay. Next we move for what is entailment. Entailment is nothing but it happens when one statement logically follows from another statement. If a knowledge base contains certain facts, we can ask whether a certain conclusions must be true if the knowledge base is true. For example, if you know it's raining, you might infer that ground is wet. Next, what is a computing entailment? It means using rules or systems to derive new facts from existing ones in the knowledge base. This allows a system to reason about informations and make conclusions automatically. Next, we move for the method for computing entailments. First is the truth table method. The method is a way of checking whether a statement is true in every possible scenario. You would create a truth table that lists all the possible combinations of truth value for facts and conclusion. If the knowledge base is true in a scenario, you check if the conclusion is true in the same scenario. This method works but can become slow and impractical for larger knowledge base because the number of combinations grow quickly. And next is the model checking. It involves creating models that satisfies the facts in the knowledge base. Then you check if the conclusion holds true of all models. This method is more efficient than the truth table for many problems because it does not need to consider all possible truth values. Only those can fit the knowledge base. Next is the inference rules. It is a proof methods. It likes the modus ponens and resolutions we already saw in the first unit. Logical steps, it is used to derive the conclusions from the knowledge base. These rules allows how the systematically derive conclusion without checking every possible model. This method is very efficient for large knowledge bases and commonly used in AI systems for reasoning. Next, examples of computing entailment. Let's go through an example. First is a knowledge base. Raining. Differs raining, then ground is wet. Raining means it is raining. Query. Is the ground wet? We ask. By using a modus ponens, step 1 from the rule raining, wet ground and the fact raining, we can apply modus ponens. If A implies B and A is true, then B must also be true. Conclusion. From the facts in the knowledge base, we conclude that, and also we can infer that we can infer wet ground, that is the ground is wet. Here this shows the knowledge base, meaning the knowledge base entails the ground is wet. Okay. Next, what is the importance? AI systems need to compute entailment to make decisions or solve problems. For example, in expert system, like we take a medical diagnosis. Okay, he uses entailment to derive the conclusions based on the rules and facts about the disease and treatments. In AI planning systems, that entailments ensures that actions taken by an agent will lead to the desired goals or outcomes. We move for the challenges. Challenges is nothing but the computational complexity. Here computational complexity means the number of models, that is the number of possible scenarios, how it grows quickly as the number of variable increases. Here making entailment computationally expensive. Then incomplete or inconsistent knowledge. If the knowledge base has missing or conflicting informations, computing entailments can become difficult or even impossible. Then efficient inference, that is the finding efficient inference algorithm in crucial in AI. Here efficient algorithm, how to find means by using a reasoning and entailment is crucial to avoid excessive computational time. These are the things occurs in computing entailment. If you have any doubt, please free to ask in the comment section. I will explain it. Thank you, Thank you, students.